So in quiz 3 we look at moles and we continue with state symbols. With moles, in this quiz, all you really need to know is that the word mole represents 6.02 by 10 to the 23. You don't even need to know that number by heart. It will be given to you in the exam question. And when it's given to you, you have to use it. If it's not given to you, you don't have to use it. And I've equated it to the word dozen. The word dozen represents the number 12. The word mole represents the number 6.02 by 10 to the 23. And you use these terms in the same way. So for example, if I told you you had 2 dozen eggs and I asked you how many eggs you have, if you know that the word dozen means 12 and you know you've got 2 dozen, then you've got 2 times 12, you've got 24 eggs. If I go from eggs to buns, it doesn't change the calculation. If you've got 2 dozen buns, it's still 2 times 12 is 24 buns. If you had 4 dozen buns, it would be 4 times 12 is 48 buns. So it's all centered around the fact that the word dozen means the number 12. It doesn't matter if you go from eggs to buns to cakes, you're just going to multiply the number of dozen by the number 12 to get how many. Moles works in exactly the same way, except in chemistry you're going to be talking about atoms and molecules, not eggs and buns. So for example, you could be asked how many atoms are in 2 moles of sodium. I know the word mole means 6.02 by 10 to the 23. If I've got 2 moles, then I've got 2 times 6.02 by 10 to the 23. You do need to be able to do this in your calculator. Apologies, my calculator's got like no buttons. But you do 2 times 6.02 by 10, you should have that someplace in your calculator, to the 23. And you get your answer in standard form, 1.204 by 10 to the 24. By 10 to the 24. If I asked you how many atoms are in 2 moles of carbon, you would do exactly the same thing. It doesn't change the calculation. You've got 2 moles. The word mole means 6.02 by 10 to the 23. You multiply and you get exactly the same answer, just like we did above. The first few questions I asked you how many atoms. That's because sodium is an atom, carbon is an atom, CO2 is not an atom. CO2 is a molecule. You don't find CO2 by itself in the periodic table. It's a molecule made of carbon and oxygen atoms. It doesn't change how you do the calculation, but the question will be worded slightly differently. Instead of saying how many atoms do you have in 4 moles of CO2, we'll say how many molecules do you have in 4 moles of CO2. So because I've got 4 moles, and the word mole means this number, I do 4 times that number. 4 times 6.02 by 10 to the 23 equals 2.408 by 10 to the 24. The only times it can get a little bit awkward, and I gave you an example of this in your booklet, is in questions 4, 5, and 6. So I asked you how many atoms are in 2 moles of water. Okay, water itself is not an atom. Water is a molecule. So what you will have to do is you've got 2 moles, so you'll do 2 times 6.02 by 10 to the 23. That gives you the number of molecules in 2 moles. So you take the 2, you multiply by that number, just like we've done. And once you've worked that out, you then have to multiply your answer by 3. And the reason you multiply by 3 is there are 3 atoms in each molecule of water. There are 2 hydrogens and 1 oxygen. And the next one, how many atoms are in 2.5 moles of methane? Again, methane itself is not an atom. So I do 2.5 multiplied by 6.02 by 10 to the 23. So I do that first, just like I've always done. And once I've done that, I look at methane and I count up how many atoms there are. There are 4 hydrogens and 1 carbon. There are 5 atoms in total. So I find my answer and I multiply by 5. In the next one, how many atoms are in 4 moles of CO2? CO2 is not an atom. If you can't find it on the periodic table by itself, it's not an atom. If you can write it as a formula and you see you've got multiple different symbols in there, it's not an atom. So how many atoms are in 4 moles of CO2? I do 4 multiplied by 6.02 by 10 to the 23. And once I've done that, I then need to multiply by 3 because there are 3 atoms in CO2. There's 2 oxygens and there is 1 carbon. So I have done the answers for you here on the next page. You work out the number of molecules, then you work out the number of atoms, okay? A further clue that you have to do more than one step is the number of marks. The first 3 you were just doing one multiplication and it was worth 1 mark. The second 3 was worth 2 marks because you had to do 2 calculation steps. The first step was the same as what you previously been doing, but then you had an additional step depending on how many atoms are in the molecule involved. Just make sure that you can actually do these on your calculator. So practice doing it on your calculator and make sure that your answers are matching mine. The other part, I asked you to fill in the state symbols. So we looked at this last week as well. And in some questions you'll be told whether it's solid, liquid or gas, but for some things you're going to be expected to know. Like if they tell you you've got a metal, and you know it's a metal because it's on the left hand side of the periodic table, so something like potassium or iron or tin, anything that you know is a metal, you're expected to know that metals are solid at room temperature. So you're not necessarily going to be told that it's a solid, you'd be expected to know that it's S. Any ionic compound, an ionic compound is a metal and a non-metal. Anything ionic, you're going to be expected to know that that's solid, unless you're told otherwise, okay? Unless you're told that they've melted it or dissolved it, you're going to be expected to know that it's solid. Again, ionic compound, a metal and a non-metal, and the reason it's solid because you've got really strong electrostatic forces of attraction between those oppositely charged ions. It's always going to be solid at room temperature. Another thing, this is what came up last week in the quiz, if it's a precipitate, that also tells you that it is solid. Liquid, if you're told something is molten, then you're going to use the state symbol L. Water, you're expected to know that it's L, okay? A lot of students write AQ for water. AQ means you've got a solid dissolved in water. If you've just got water by itself with nothing dissolved in it, then you're going to use the state symbol L, it's a liquid. Gas, there's a couple of gases you'll be expected to know. CO2, O2, N2, they're the gases we have most commonly in the atmosphere. You're expected to know that they're gases at room temperature. Hydrogen's a gas at room temperature. And then methane and ammonia, we do study these 2 gases more in another topic, but you are expected to know they're gases at room temperature. And then again, if you're told something is aqueous or in solution, you're going to use the state symbol AQ, but you are expected to know that acids and alkalis are always AQ. So if I look at the practice questions, hydrochloric acid is reacted with the alkali sodium hydroxide. So I'm told hydrochloric acid is an acid, I'm expected to know that the state symbol is AQ. I'm told sodium hydroxide is an alkali, I'm expected to know the state symbol is AQ. To make sodium chloride solution, it says solution, then I know it's AQ, and H2O. I'm expected to know that water is a liquid. Magnesium metal, okay, they've told me I've got a metal, I'm expected to know that metals are solid at room temperature. Is reacted with hydrochloric acid, again it's an acid, I need to know that that's aqueous. To make magnesium chloride solution, they've used the word solution, I know that's AQ. And hydrogen, I'm expected to know that hydrogen is a gas at room temperature. So again, sometimes they'll tell you, and here you can see that they've told you when something was a solution, but there are certain things you're expected to know. Metals, ionic compounds, precipitates, solids, water is a liquid, a couple of common gases, and then any acids or alkalis are going to be AQ.